Welcome to Turn Right Machine Works. My name is Keith. Alright, we got a piece of mechanical tubing in here and we put it in a 3-jaw and we brought our bell center in and we touched the center there and we kind of tightened it all up and we got it running nice and true. Now we came over here and we just barely touched it right there and we're just going to take like, I don't know, 10-15 thousandths. All we want to do is get a good clean cut across there. And looks like I'm going to need a new brush and a little bit more fluid there. And before I actually start skimming it. But we're going to face across here. And then we're going to put a bell center in there and we're going to turn the OD for our press fit. That's the most important thing, is that press fit. And then we're going to cut it off and we're going to face it to length and we're going to put it in the 3-jaw again and we're going to rough it down to where it's, I don't know, maybe 20-30 thousandths from being finished size for that bearing, so we don't really have to work real hard in the Bridgeport on getting the bore. And we know that there's not going to be any problems getting a smooth finish on this in the Bridgeport because that boring head and this surface is new, and we're not going to have any of that poison cast iron material that we've had to dick with over there because somebody had to brain fart to weld cast iron to a steel race bearing. Go figure. Today I'm using one of the very first inside machinist tools that I've acquired in my collection, and Maynard Sorensen was my supervisor in Atkinson Marine, and this was his, and this is a homemade box, and it's quite old set of Starrett inside micrometers all the way up to 8-inch. Alright, and everything in here is original, and that's what I'm going to be using to mic up this bore. But I wanted to share something with you, and even though Christ, he was an old dude when I was back in early 80s, alright, he may be passed on, but I still remember him and what he did for me, and where I'm at today is because of that. And that's one of the tools that I really hang on to and enjoy using quite a bit. Alright, we got 3 inches, 360 thousandths. Alright, so that's the number we're going to play with. Let's, like I said, you always double check it with an outside micrometer, because actually we're going to be measuring that part that's going to go in here with the outside micrometer. And even if both of these are off, if we knew exactly, see, the micrometer now is reading 3 inches 62, and this could be chilled from being in the cupboard, this could be warm from the hand, there could be a little grit of shit in there. Alright, so as long as we got that difference, and that's what the main thing is having that difference there. And we're going for our own design of press fit in here, so we're not trying to calibrate or manufacture something that's going to be sent out and assembled somewhere else and be responsible for that size. And that's why you need to have certified tools and stuff like that, is if you are manufacturing something that's going to go on out. Now if we were doing that and I really wanted to, I can get out my standards and double check and make sure that either the micrometer is right or the inside micrometer, whichever one, you know. And that takes you back to calibration dates on here, May 3rd of 85. All right, that's how long it's been since I've been working for a company that I had to have certified tooling. And of course I'm not doing government jobs or anything in the line of needing certified tooling. Alright, let's go on over to the lathe there, and we're going to continue on, and we're going to create an OD of, I like to see 3/1000 press in here, because we know that we're going to probably be about 1/8 of an inch wall thickness, and we don't want the thing coming loose. and we have a we don't want to go there. Let's go play over here. All right, we got a OD here that's 3.5, or about 4 thousandths over 3.5, and so we got we've got a 1/8 of an inch or so to take off of this, and we're going to go ahead and we're going to take a skim here, and our part is only really going to be about a 1.5 inches, maybe about 1.4 inches, somewhere around in there, but we need a part off for a saw cut. So we're going to go ahead and we're just going to go ahead and we're going to make this 2 inch long so we can play with that diameter. All right, 3/4/46. Okay, that was our finished cut, and we should be down at 3 inches. 360, 60.5. All right, so we can polish a 1/2 thousandths off of that, no problem. All right, because our bore was 3 inches, 56.5, 57, and we were shooting for like 3 thousandths press. We have about 3.5. Is that what we have? We got like 3.5. Light little polish on there, and we'll be able to bring it down to size. Actually, I think we're just going to polish it a little bit. We're going to go cut it off right now. All right, we've just touched off and took a skim. We've already got that down to the width that we want for the bore, and it's pretty close to the bearing diameter there. 1/370, and we know it's 1/3/8 there. And that's about, we went 1/350 or so here, because that's all that the thickness is on the flywheel. All right, the genuine NTN bearing, and we're just using our calipers here right now, but it's actually, I think it's a millimeter bearing, 80 millimeters. But anyway, 31475 is our measurement here, and we got 2595, so we've already taken, well, we took 50 thousandths after we touched because we knew we needed to open it up. So we're going to go ahead and open it up to about 3 inch, 80-90 thousandths or so. We want to go ahead and leave ourselves about a 1/16 of an inch and to play with over in the Bridgeport. Like 2790 or so, 27 98, 27, it's like 2,800 almost. Okay, so 2,800. All right, let's go another 50. All right, we got like 2,900 right now, so we're at almost 3 inches, and we just want to end up with like 3 inches, 60 thousandths or so. So we're just going to take another 25. We're going to call this a finished cut, and then we'll go press it in.
How's that expression? When a door closes, another one.
All right, really, I don't think it matters which way. We'll go ahead and we'll put it in that way there, and we're going to put a flat plate so that we can make sure that we're going to be coming down to that surface there, or it'll be hitting the bottom at the same time. And then this is just going to be a plate here. And I think we may have enough travel. We may have to put something in there, but let's see what we got here. We're going to bring it down and kind of center it anyway. I like that. Okay, she flushed out on the bottom side. I kind of figured that I was like about 20 thousandths. Yeah, about 20 thousandths up above that surface right there, which it doesn't matter. The bolt circle is still going to make it out here. All right, good. Oh, gotta have things out of your way here. All right, we just lifted this up and just wanted to point out that's nice and flush back here. So, and this, this is still good, and we're gonna. This is the surface out here that we actually set our parallels on the table there. Right, we got our parallels back underneath here, and actually we have a little bit more. We only had 5 thousandths pitch in it last time, and now, so it just kind of leads me to think that maybe it might be a little bit of debris or something on or the surface here is not running. But what we're going to do is we're going to go ahead and set it up, and we put 2 parallels down here stacked on each other, flat across the ways, so there's no damage to those ways. In fact, actually that's not even way contact area right there, but it is politely sitting on there and using it as support. Now we're not moving our table, it's already pretty well centered. So what we got is 2 miniature screw jacks here, and we're going to go ahead, and we got the dial indicator up here, and we're going to go a little side to side. There's like 3, there. Actually, I got to come back a little bit because I can't get my Allen out of there. All right, and we're going to go a little bit more on the other side. And I'm going to have to look around this side here. Okay, that's like 8. Alright, we're going to go around here now and reset our indicator here on this side here at 0. And we're about -5. Now here in between, -6. So this side over here needs to come up more than that side over there. Alright, let's swing around again. This is looking pretty close. There's 0. Within a half. That's about 4. That's like 1. Okay, now we're going to check our peripheral again, and then we're going to call it good. Alright, now we're sweeping it here, and we got 0 there, and we got like 12, and 0. Alright, so now we're going to go ahead. I'm going to crank in about 5 there. We're going to go ahead and put 0 here. Okay, we're going to crank in, bring it up to 0 here. Pretty close to 0. 0. 0. 0. Alright. We're at 0. We're locked down. We're tight. Let's bore it. We just spun it around and we touched off, and we're gonna go ahead and we're gonna take 15 thousandths on the diameter. That's only like 7.5 on the radial, and we're still pretty close on our start and stop. We're gonna be speeding it. We're gonna go ahead and we're gonna raise up the speed a little bit because we got good cold roll material there. And bringing it on down. There's where she touches. Engage it. Now we're going to be running a little bit of oil on this one here. We're going about 80% around. And that could be simply just the way that bearing's pressed in or cocked in there. Also too, we just threw that in a 3-jaw and threw in a rough bore. So that's why we didn't bore. That's why we didn't dial that bore in to start with. If this was upside down, we would have done the flywheel, but I was taking this larger diameter, which gives you a better reading, and you'd be more accurate in the long run with the larger sweep and the larger diameter for flatness. Right, we had just about a straight across point here to measure that, and we got 3 inches 50 thousandths, basically plus or minus a couple thousandths. Alright, so now we're ready to go ahead and do our first setting here, and we're gonna, now that we know we've got almost 100 thousandths to take out of this bore. So we're going to go ahead and we're going to drop in here with about, yeah, cranked in about 20 from where it was on the diameter. So, and that's what that dial is diameter dial. Okay, we are 100% round now. Alright, we finally got back to this. We had to take care of a few other things here, but anyhow, we're just double checking so that we get back on the same thought we were at, and we're 3 inches 119, and we got to go out to, and our bearing is 3 inches 148. Alright, we're going to sneak up onto this, and we're going to take 10 off the diameter here. After this, we should be pretty close to a 5/1000 finished cut per side. Let's get it engaged here. We jacked in 9 thousandths what we actually needed to take per side there. Somehow I was 5 off of there, and thinking it was going to be like 4.5 thousandths or so, but it's actually 9 thousandths we're going to take on the finished cut here. So this is our attempt. Down to the last 1/8 of an inch here. Come on, baby. 147 and about 3/10. Surface condition. Can we get a thou out of that or not? Let me check it again in another spot here. Same thing. All right. Okay, we're gonna go for we're gonna polish that out to size to get the rest of the fit. It is some close. Polishing it up smooth so we can get this thing to be a real faint tap into there. Like right on the verge of making it in there. A little bit of polishing. I think we're going to get our emery strip. That'll cut real fast. All right, we got this thing in here. Oh yeah. Okay, that's a good fit. I like that fit. And I can push it all the way through. I can lightly tap it that way. And lightly tap it that way. Okay. If we go any looser fit, the thing's going to want to spin. And so I'm happy with that fit, and I'm gonna say that's a get her done, despite the damage they caused. I won. Get her done.